Good day, students. Day 21, continuation with current electricity. Okay, today is Ram Navami, so wish you all a very happy Ram Navami. Right, so let's start. We are on our way. So see then, this is a simple circuit and we have to find what? Resistance between AB. Okay, so what we can say in this? This is A, this is B. Okay, so here if we see that, if suppose that current is moving like this, so this is moving in this way, here there is a junction, it is getting split. Okay, so whatever current goes here, same current goes through this, that means these two are in series. Same way, sorry, this is I2 I have written, this is I1. Okay, so here is I1, right. So current which is going here is also going here. So this is in series, so net resistance here 6. Exactly same thing is here. This is also 6. Okay, now this 6 ohm and this 6 ohm are parallel. So 6 ohm and 6 ohm are in parallel means 3 ohm, R1 R2 by R1 plus R2. 6 into 6 by 6 plus 6, 3. So 3, then this 3 and this 3 are in series. So 3 plus 3 plus 3. So it becomes 9. So here is 9. And here is 6. And this is AB. What we can say about 9 and 6? They are parallel again. What is RAB? We know RAB is equal to R1 R2 by R1 plus R2. 9 into 6 by 9 plus 6. 54 by 15. We can simplify that. Okay, clear? Alright. One more simple question. Very simple question. Current is here 0.5 ampere. It's going into this junction 6, 6, 6 here. And there here is 12 and 6. Find Vp minus Vq. So first let's find out what is the resistance here. So 6, 6 and 6. That means connected parallelly. So 1 by 6 plus 1 by 6 plus 1 by 6. That is 3 by 6. That is 1 by 2. So R is equal to 2. R1 we will say. R1 equal to 2. Now this is 12 and 6 are parallel. So this we can easily find. 12 into 6 by 12 plus 6. Answer is 4. So this is 2, this is 4. Net resistance is 2 plus 4, 6. 2 ohm, 4 ohm, 6 ohm. And here is 0.5 ampere current. What question is asking? Potential difference between P and Q. So delta V equal to IR. So 0.5 into 6, that is 3 volt. I into R, that is 0.5 into 6, that is 3. Answer is 3. Simple question. Right. Then this one. Again looks simple, right? Current is coming from here, resistance AB. Okay, fine. Current is going from here. These two are in series. And these two are in series. 3 plus 3, 6. 3 plus 3, 6. Then they are connected parallelly. So 6 and 6. Those two are connected parallel. So what will come? 3 ohm. Here also same. Here also same. So 3 ohm, 3 ohm, 3 ohm. This is A, this is B. Net resistance 9 ohm. Correct? Okay, then find VA minus VB. Okay. A is this one and B is this one. And what you have, this is a battery. Okay. And this one I have not given you. Right. So let me check what is its value. Okay. So just a minute. Just check that. Three ohm. Okay. That's also 3 ohm only. Okay, fine. We'll keep 3 ohm. Okay. Now, how to do it? You have to find potential here. So what you'll assume? Here is 10 volt and here is 0. So here is 10 and here will go 0. Alright. Now let's talk about resistances. This is 3 plus 1, 4. This is 3 plus 1, 4. 4 and 4 are connected parallelly. So that means that means 2. 4 and 4 connected parallelly. That means net resistance will be 2. This 2 plus this 3, 5. Total resistance is 5. And battery is connected 10 volt. So what will be the current? Current will be 2. Again, this is 4. This is 4. The net resistance is 2. 2 ohm plus 3 ohm, 5. And battery is of 10 volts. So current will be 2 ampere. Okay. So now here is what potential? 10. Now here from here what current is passing? 2. 2 into 3, 6. 6 will be the potential drop on this. 6 will be the potential drop on this. So how much will be here? It will be 4 volt. Here will be 4 volt. From here what current is coming? 2 ampere. Here what is the resistance? 4. Here what is the resistance? 4. So it means it is going to split. There is 1 ampere here, 1 ampere here. Because here and here resistances are same, so it will split into 2 equal magnitude currents. Okay, so here also 1 ampere, here also 1 ampere. Okay. So here this through 1 ohm, this 1 ampere is going. So how much potential will drop on this? 1 into 1, that is 1. Here what is the potential? 4 volt. Here drops 1 volt. So here comes 3 volt. Same way here. Here is what? 4 volt. So here 1 ampere is going to 3 ohm. So how much will drop here? 1 into 3. That means 3 volt will drop. So 4 minus 3. Here will be 1 volt. So what is VA minus VB? 3 volt minus 1 volt. That is 2 volt. Okay. VA minus VB is 2 volt. Okay. We could have done with the junction method of Kirchhoff's also. Like this is there. This will be current. This will be the current. That also we can do. Okay. That is also possible. But before that, you have to still find out what is the current rate. So this method is better than that. Okay. Alright. See now what this is. Similar question we have done before. We said it was Wheatstone bridge. Wheatstone bridge? No, it was not Wheatstone bridge. It was we took junction method, parallel. We found out that these three are parallel. Here also they are parallel, but resistances are given in different. What parallel? We said that if this is potential, here is potential at A. Okay, this point is A. Then this point also will have at the same potential. We can say this is also A. And if this point is at B, we can say this point is also B. So across this resistance, what is the potential difference? VA minus VB. Across this also VA minus VB. Across this also VA minus VB. So all three are parallel. So if that is so, then we can write 1 by RAB equal to 1 by 2R plus 1 by 2R plus 1 by R. LCM 2R, 1 plus 1 plus 2 equal to 1 by RAB. So RAB equal to what? 2R by 5. 2R by 5. Okay. Is it correct? Go ahead and correct or not? 1 plus 1. Oh, I have done a mistake. This is not 5. This is 4. 2 plus 1 plus 1. So 4. This is 4 by 2R. So this will become 2R by 4. So R by 2. Okay. Fine. Now what is this? See, there is a 40 ohm resistor connected across 120 volt battery, and this is also 20 ohm resistor. So what is he asking? What is the potential difference between X and Y? But is this open circuit here? Answer is yes, this is open. So open is there means there is no current in that. I is 0. If I is 0, across resistors there is no potential drop. So if I say here, this is 0 volt and this is 120 and here is also 120. And how much is current in this one? No current. So here is also 120. Same way this is 0. What is the current in this one? No current. So this is also 0, 0, 0. So what is Vx minus Vy? 120 volt. Vx minus Vy is 120 volt. Okay, let's see. Okay, multiple batteries are here in this one, and we have to find current. 28 ohm, 54 ohm, and we have to find current. So what to do? Same way. Let's assume where is 0. So assume that this is 0 for us. A 0 means just connect with the earth. That 0 volt is here. So if this is 0 volt, you see here you are moving from higher potential to lower potential in a battery. So here will be minus 8. Here is minus 8. Okay, here is 0. From 0, you are going to higher potential of the battery. You are increasing it by 8. So here is 8 volt. Here, you are moving from higher to lower. So this is minus 12. And this is also minus 12. Okay, so now we have to see how the current is moving. 8 volt to minus 8 volt, definitely. Higher to lower only potential will be. Same way 8 to minus 12, it will be like this. So there will be I1, this will be I2. Correct? What is I1? Let's see. What is the potential difference? 16. So 16 equal to 28 into I1. So I1 value is 16 by 28. This is 4, this is 7. So 4 by 7 ampere. I2 you see, 8 minus minus 12, that is 20. So 20 equal to 54 I2. So I2 equal to 20 by 54. Okay, how can we cancel that? Okay, let's do it with 2 first. 10 and 27. So 10 by 27, that's it. Okay. And here what it is? Here is 4 by 7. So 4 by 7 is here, 10 by 27 is here. What is this I? So that means I we have to take in opposite direction. Okay, one is going in this one is going in this one. That means I equal to I1 plus I2. Direction need to be changed. This is I. So I equal to I1 plus I2. So what that is? 4 by 7 plus 10 by 27. Then we can add it. Okay. 56 we could have made, right? 56 would have been, this will be 28. So it would have been easy for us to solve. But okay, fine, whatever is that. Okay, right? So this is how I2 is going in this way. This is how I1 will be going. So I will be equal to I1 plus I2. Okay. See this one now. One more question is there. In a closed loop, VAB equal to 4 volt. Okay, VAB equal to 4 volt. So find X. Okay. Why don't we have Kirchhoff's loop law like this? Let's see what's coming. Let's start from the A. Okay. So VA minus 10I. From here higher to lower, so minus 5 minus XI plus 2 equal to VA. VA cancelled. So we have got one relation over here. What is that? Minus 10I minus XI. Okay. So minus I into 10 plus X. Then minus 5 plus 2, that is minus 3 equal to 0. Okay. Alright. So I value, that means we have taken, this is in wrong way, we could have taken in that way. Fine, no issues in that. So I equal to minus 3 by X plus 10. Okay. So far nothing we have got, but I value is there. Now what we will do? Let's move from A to B, because he says VAB equal to 4 volt is there. Okay. How to go? You can go like this one. Then only X will come. Right. Let's move like this only. So VA, this is minus 2. Okay. Now you took current like this, and you are going opposite to the current. Your direction is like this. So opposite to the current, that means here plus Ix I will be writing. plus Ix equal to VB. Okay, VB you bring that side, that you take that side. So VA minus VB equal to 2 minus Ix. So this is 4. 4 equal to 2 minus Ix. So 2 equal to minus I into X. Okay, I values here. Let's put it. So 2 equal to 3 by X plus 10 into X. Minus adjusted. So 2X plus 20 equal to 3X. So X appeared to be 20. X is 20 ohm. Okay, X is 20 ohm. Right. So that is fine. If I have not done any mistake, VA minus 2 plus 2X plus Ix equal to VB. That's fine. And here VA minus 10I minus 5 minus Xi plus 2. Yes, fine. Okay, so that's the answer. X is equal to 20 ohm. Then find Vp minus Vq and also find I. Okay. Alright, again closed loop is there. So let's write the loop law. From loop law, we'll be getting I value, and once we got I value, we'll be getting Vp minus Vq also. Okay, so it's moving like this, let it go like this one. So from here, Vp we are starting. Okay, so minus 9I minus 2I plus 8 minus 4 minus I equal to 0. Minus 11I minus 12I. Minus 12I and 8 minus 4 plus 4 equal to 0. So I appears to be 4 by 12, that is 1 by 3 ampere, and positive, that means we have taken correct direction. Now Vp minus Vq. So like this only we can go. So Vp minus 9I equal to Vq. So Vp minus Vq equal to 9I, and I is 1 by 3. That means this is 3 volt. Okay, this is 3 volt. This is just Kirchhoff's law, okay, nothing else. Loop law. From here we started like this. Okay, potential drop across all the elements need to be 0. Sum of potential drop across all elements should be 0. Okay. Alright. So 3 resistors are connected, 60, 20, 10. 1 ampere is coming from here. We have to find what is I1, what is I2, what is I3. Are they connected in parallel? Yes. So I is equal to V by R. That means I is inversely proportional to R. So I1 is to I2 is to I3 equal to 1 by R1 is to 1 by R2 is to 1 by R3. Now we have to decide. Okay, this we have to decide only R1, R2, R3. Okay, so see now R1 is what? 60. So 1 by 60 is equal to 1 by 20 is to 1 by 10. 1 by 60 is to 1 by 20 is to 1 by 10. Right. Then what you will do? Multiply 60 on all sides here in numerator. So 1 is to 3 is to 6. Okay. I1 is to I2 is to I3 is equal to 1 is to 3 is to 6. Now what shall I do? So I1 by I1 plus I2 plus I3 equal to what? 1 by 1 plus 3 plus 6. Correct. What I did in the left side, same thing I have done in right side. So I1 I have to find. What is I1 plus I2 plus I3? 1 ampere. So 1. Here is 1 by 10. So what is I1? I1 is 1 by 10. Exactly same way I2. So I2 by I1 plus I2 plus I3 equal to what? 3 by 3 plus 6 plus 1. Okay. So this is what? 1. And this is 3 by 10. So I2 is 3 by 10. then obviously I3 will be 6 by 10. Okay, I3 will be 6 by 10 because total has to be 1. No? Okay, so 1 by 10, 3 by 10, so this will be 6 by 10. Simple. Okay, now what we have? Cells. A cell or a battery. How is cell or a battery? Cell or a battery, normally we till now we are doing it like this. Okay, so we are talking about EMF of a battery. Now EMF of a battery is actually the maximum potential difference that we can obtain across a battery, or ideal potential difference that we can find across a battery. That's called EMF of a battery. Work done by a battery in moving a charge from one terminal to another terminal is called EMF of a battery. Okay, ideal. We represent this with E. But are we going to get ideal? No. Whenever we are going to use battery, if you touch it, it will be hot. So that means some amount of energy is converting into heat. That means we are not getting the total energy of the battery. We are getting less than that. Because there is internal resistance in the battery. So some amount of energy is utilized in overcoming that internal resistance. And that internal resistance we write like this. This is internal resistance, or we can put it here in the middle if we want. Okay. So how much energy are we going to get if we are using a battery? Okay. So we are getting the potential difference across the battery that we get. If suppose we are using it across this external resistance and this is I. So across this battery, how much potential difference is there? That is what we are getting as energy. And what this is? So VA minus VB is equal to E minus IR. VA minus VB equal to E minus IR. And what is I? I is E by R plus R. What is E? EMF. And this resistance we calculate along with the external resistance. We say that now total resistance is R plus R. Not the only R, R plus R. So I becomes E by R plus R and terminal potential difference is E minus IR. So this is terminal voltage. This is current. And what is EMF? EMF is E. What is EMF actually? Ideally, how much a battery wants to give us. What are we getting? We are getting this much. Because battery is having internal resistance, so some amount of energy is dissipated in the form of heat. What energy is dissipated? This energy is dissipated in the form of heat. Okay. And what is the current we are getting? E by R plus R. We will remember that. Okay. Series connection of cells. Now you are connecting, suppose, N cells in series. Okay, along with resistance is also there. E, R, E, R, E, R, like that N. And then there is external resistance also. So if we have connected N cells, how much is the net EMF we are getting? Single was there, we have written EMF is E. If there are N, we will write that net EMF is NE. Net EMF is NE. Same way, what is the net resistance? Now R, like that N. So NR will be the net internal resistance. And then you have connected them with external resistance also. So what is net resistance? Net resistance will be total internal resistance plus external resistance. What is net internal resistance? NR plus external resistance R. So what is I? I value will be NE by NR plus R. Okay, when to use series connection? When R is greater than NR. When external resistance on the higher side, we use series connection of the cells. Okay, remember. Parallel connection. So parallel connection also is there, like this. Okay, like this there are N batteries. E, R, E, R, E, R. Okay. maybe n branches, and then finally there is one external resistance. So across each branch, because now here potential difference between first branch, second branch, third branch is all same, because they are all connected over here in parallel. This is the common terminal here. This is the common terminal here. So potential difference across this need to be same. Okay. So what is potential difference across this? You can write E minus IR. But I am asking net EMF now. What is the net EMF across this? So E, here E, here E, here E. So net EMF is what? E. Net resistance. Now we can see that all resistances are connected in parallel. Which resistances? These internal resistances. They are connected in parallel. So what will be their net resistance? 1 by R net equal to 1 by R plus 1 by R plus 1 by R. That is N by R. So net resistance will become R by N. Then it is connected with the external resistance also. So plus R. Current will be net EMF by net resistance. Okay. Net EMF by net resistance. So this is parallel. Okay. Alright. See now. Now this is connected in series, but their EMFs are not same. This is R1, this is R2, even the internal resistances are also not same. So what we have to do? We have to find I. So what to do? Kirchhoff's law. Okay. Just move in the Kirchhoff's law here. I is the current. Okay. Let's move. First is minus IR. Minus IR2. From here now you are going from lower to higher, so plus E2. Again minus IR1. And again plus E1 equal to what? 0. So I value will take one side, on the other side will take E1 and E2. So minus IR, minus IR2, minus IR1, take that side. Here is E1 plus E2 and here is I, R plus R1 plus R2. So I value is what? E1 plus E2 by R1 plus R2 plus R. This way we find. Series connection. Okay. Alright. Then parallel connection. E1 R1, E2 R2. Its derivation is slightly longer. So I try to explain you with the simpler method. What is this? Just check. What it is? This E1 by R1 plus E2 by R2 actually is equal to E combination by resistance in parallel. R1 R2 by R1 plus R2. Resistance in parallel. Okay. E1 by R1 plus E2 by R2 equal to E combination by RF combination, you can say. Then VAB. Now VAB means potential difference across these two. That means you can say like terminal voltage of a battery. Now this is combination. This one combination is there. Okay, combination of a battery we have got. So this is terminal voltage. So terminal voltage used to be what? E minus IR. We written no. V equal to E minus IR. Where we did that? Here only. Yes. See. Exactly same thing we are using in this one now. See. VAB equal to E of combination. That means E of this minus I into RP. Why RP? Because combination. This combination. Not this. This combination. V equal to E minus IR. Remember that. First is E1 by R1 plus E2 by R2. E combination by RP. Okay. VAB equal to E combination minus IRP and RP we all know. Net resistance is RP plus R. Okay. Suppose current we have to find. So current will be what? What will be current? Now I can write VAB minus IR only. Total R combination. But from here if we have to find, then it will be like E combination minus VAB by RP. We'll see that. Okay, let's do the question on. Let's do the question, we'll understand. Here it is. Similar question, this is 4 volt, this is 2 ohm. Okay, 4 volt, 2 ohm, 6 volt, 2 ohm. He says first find E of the combination. So we know that E of the combination by resistance in parallel. Resistance in parallel means is what? 1 equal to E1 by R1, that is 4 by 2, plus E2 by R2, that is 6 by 2. So 2 plus 3, 5. So 5 volt. E of combination is 5 volt. That is it. Okay. Then what we have? I of combination. What is I of combination? What you can say? Now, I of combination is E of combination by total resistance. R of combination. E combination we already got 5. Now, R of combination is what? Now these two together are 1. 1 plus 6, 7. So I is equal to 5 by 7 ampere. Then VAB. VAB we know. E of combination minus I to RP, that is parallel combination. So E is what? E is 5. I is what? 5 by 7. RP is 1. So 5 minus 5 by 7 volt is our answer. That is what? 35. 35 minus 5, 30. 30 by 7 volt. This way also we can find, or we can say that same current should go through this also now. So VAB will be equal to IR also. That is also you can do. I is 5 by 7. R value is 6. So 30 by 7. Both are same answers. Okay. So like this we should be doing it. E of combination E1 by R1 plus E2 by R2. Okay. Resistance R1 parallel resistance R1 R2 by R1 plus R2. Okay. Right. See then what this is. A cell of EMF E is connected with external resistance R, then potential difference across cell is V. The internal resistance of cell is. Okay. So cell of EMF E connected with external resistance R, then potential difference across cell is V. So that means he is saying V is equal to E minus IR. We know that, right? Internal resistance only is asking, and I is what? I is also, I know it is E by R plus R. We have seen that. The same thing I am writing. Okay, I is equal to E by R plus R, and small r we have to find. So one way is we can find it from here itself. Everything we have, yes or no? That is E minus V by I equal to R. E minus V by I equal to R. Okay, but whether this is given as the answer or not, we don't know, right? But one more thing is there, right? What is that? I equal to E by R plus R is fine, but I is also equal to V by R. How? Just see. There is this battery. Here is internal resistance, and this is external resistance. This is some A and B. So VA minus VB, we are saying is E minus IR. Now my question is, what is potential difference across this battery? VA minus VB. So VA minus VB equal to what? IR, same current, no? Correct. So I is equal to what? V by R. So here I can write V by R, right? So small r will be equal to E minus V by V into R here. That's all, finished. So all the things which are there, E is given, V is given, and capital R is given. So we have written small r in terms of those. I could have kept here again this one. Then it could have been a bigger one. Why? Because here again small r is coming. It could have gone longer. So that's why we thought that why not place it like this. So we got the answer. Okay. N identical cells of EMF E and internal resistance R are connected in series with external resistance R. Find current through R. That we did already. I equal to NE by NR plus R. Correct? Yes. Okay. Now let me make one more question from here. If suppose that we have N cells in series, N cells in series connection, N cells of EMF E, okay, N cells of EMF E and internal resistance R. Connected in series. Then what is current? Current will be net EMF NE by net resistance NR. Capital R is not there. External resistance I am not attaching here. So what is current? E by R. Okay. Now if suppose N cells of EMF E we are connected in parallel. Same we are doing in parallel. Same in parallel. Then what happens? I equal to E by R by N. So I is coming NE by R. So if external resistance is not there, then where current is more? Series or parallel? It's parallel. And series what is E by R? Parallel is NE by R. Okay, remember that. Okay. Alright. Power and bulb. Okay. We all know, we are all familiar with bulb. Okay. But bulb has got something like rating. When you go to the shopkeeper, you will say that, okay, I want 40 watt bulb. He will give you. But there is one more point written on that, that is 220 volt, which is our supply. Supply at home is 220 volt. So it means is if you are going to put this into 220 volt, it is going to give you 40 watt of power. Okay. If supply at your home is less than 220, then it will give you less power. Okay. If supply, V supply is less than 220, then power also will be less than 40 watt. When you say okay, if it is more than 220, then what will happen? Bulb will fuse. Bulb will fuse because maximum itself 40 watts. Okay, so this is called what? This is called rating. Now the question is, what is power meaning here? What is power? Power is actually V into I. Potential difference into current. V into I. And its unit is what? Watt. Okay, this we can write in terms of I also, that is I square R, or we can write it in terms of V square by R. This is power. Okay, this is power and this is rating. Through rating, what information we can get? Through rating, we can get resistance of bulb. How? Because rating is this 220 volt and 40 watt, and P is equal to V square by R, we know. So if P equal to V square by R, then I can write R equal to V square by P as well. So V is given, P is given, R we can find. So with this rating, we can easily find out what is the resistance of the bulb. Okay. Alright. Combination of bulb. Okay. Series and parallel. So series is this. The two bulbs are here. Okay. This is P1 and this is P2. And they are connected across a battery. Okay. Now, which bulb is going to glow more? Now, we know that if there is a series connection, the same current is going to move in both. No doubt about that. So, whichever is having more resistance will glow brighter, no? Power output is what? I square R. So P1 will be I square R1, P2 will be I square R2. So whoever is having more resistance will glow brighter, whichever is having less will glow less. Reason? Series connection. Parallel. Okay, this is parallel now. It's P1, this is P2. And here, this is battery, whatever that is. Now in this one we know that across this bulb also potential is V, across this also potential is V. Then what will be the power output? Power output is going to be V square by R. Why? Because V is common in this. So in this one, that means power is actually inversely proportional to R. So whoever is having less R will give you more power. Here proportional. P is proportional to R. Whoever is having more R will give you more power. In this one, whoever is having less R will give you more power because P is inversely proportional to R. Clear? Parallel. Okay. See here what it is. 50 volt to 25 watt and it is connected across a 20 volt bulb. Find resistance of the bulb. Okay, let's find resistance of the bulb first. What is resistance of bulb? Rating potential difference by rating power. So 50 volt, 50 into 50 by 25. So 100 ohm resistance of the bulb. Then I, simple, resistance value 100 and battery is 20 volts. So 20 by 100, it's 1 by 5. Then power dissipated across bulb. Power is I square R. What is I? 1 by 5 square. R is 100. Answer is 4. How much watt it can give? 25. How much you are taking? 4 only. It's giving it. Okay. So 4 watt only is the power output of the bulb at the moment. Okay, let's see. Two bulbs of 200 volt 40 watt and 200 volt 100 watt are connected in house. House means is what? Parallel connection. Find net resistance. Okay, very simple. Now they are connected in parallelly, we know. So I have to find its resistance. I have to find its resistance and then connect it parallelly. So simple. So R1 is what? R1 means V square by P. That is 200 into 200 by 40. And R2 again 200 into 200 by 100. Okay. So this is 5. This comes out to be 1000. And here this is 400. They are connected in parallel, remember, in house. So parallel resistance means R net will be R1 R2 by R1 plus R2. So 100 into 400, not 100, 1000. 1000 into 400 by 1000 plus 400, that is 1400. This and this gets cancelled. So this is 2 and this is 7. 2000 by 7. Oh. Right. Okay. Two bulbs with resistance ratio 1 by 2 connected in house. House means again parallel. What is P1 by P2? Parallel means is what same? Current or potential difference? Potential difference. So potential difference when same, then P is written as V square by R. That means P is inversely proportional to R. Means P1 by P2 equal to R2 by R1. And R1 by R2 is given. So P1 by P2 is actually 2 by 1. That's all. A heater coil is cut into two equal parts. One of these is used for heating. Heater coil is cut into two equal parts. Okay. Find ratio of heat produced by half coil to full coil. So if I assume that full coil's resistance is R then half coil's resistance will be R by 2. Ri initial is R, R final is R by 2. Okay, now in house it is connected. We are connecting it in house. So that means across 220 volt you are connecting. Right. So in this one, heat developed. I'll say that something like I square R into T, or power we should say. Don't go for heat actually, because 1 second will be the time. No, that's why power will take. The power is I square R. Now I is what? V by R whole square into R. That means I am saying V square by R. Here power final. Here also V square by R, but here is V square by R final. Here is V square by R, here is V square by R final. What is the question asking? Ratio of heat produced. That means the ratio of power, same. If 1 second I am going to use, then power is equal to the heat produced in 1 second. Okay. So P1 by P2 equal to same now. Then R final by R initial. R final is what? R by 2. And this is what? R. So answer is what? 1 by 2. Correct? Clear? Correct only, no? You have done it correct, right? Yeah. Then which bulb will fuse? 25 watt, 220 volt, 100 watt, 220 volt, 300. So across this also 300 volt, because they are connected in series. Oh sorry, they are connected in parallel. This is 300 volt and this is also 300 volt. How much is its capacity? 220. 220. Both will fuse. We are applying more. Power supply is more than power rated. So it will fuse. Both, not one. Both will fuse. Okay. Find power of the combination here. Both are connected in parallel. So both 220 volt, 220 volt. And this is also 220 luckily. So no problem. This is also going to give us 40 watt. This is also going to give us 40 watt. So what is the total? 80 watts. What else? This is also 40. This is also 40. The total is 80. Current in bulb changes by 1%, then power changes by. So power I square R or V square by R. Huh? What shall we take? Bulb it is. So bulb's resistance is constant or changing? Constant, because it depends on rated power and rated voltage. Constant resistance. Okay. So constant current will be flowing in that. So P will be what? I square R. And moreover, question is also asking that only. Now, if current changes, then power changes. So resistance is constant. So what do you say? According to the error formula, dP by P equal to 2 di by I. Done. 2 into 1%. So answer is 2%. Power changes by 2%. Okay. A bulb of 30 volt, 90 watt is connected with 120 volt line. What resistance to be connected in series with the bulb so that it doesn't get fused? Okay. So it is like you have got a one bulb here, you want one resistance to be connected, this we do not know, and you have connected with a battery of 120 volt. Okay. Power is 90 watt and maximum potential that we can drop on this one is 30 volt. That means remaining 90 has to drop on this. Okay, let's find its resistance first. What is the resistance of the bulb? So resistance of the bulb is 30 into 30, that is V square, by P, that is 90. Okay, it comes out to be 10. This is 10 ohm. Okay, this is 10 ohm. So on 10 ohm, if we want 30 volt to drop, that means how much current we can afford? 3 ampere. 3 ampere is maximum current. And here what do you want? 90 volt. 90 volt. So how much should be R? 90 to I into R. So 90 equal to 3R. So R is what? 30 ohm. So if you have 30 ohm here, that's all, we are saved. This is 30, this is 10, 40. So current will be 3 ampere. Done, over. We can save the bulb. If it's more than 30, even better. Then current will not reach even 3 ampere. Okay. This is the maximum current, remember. Alright, last topic, meter bridge. A meter bridge is based on Wheatstone bridge. Wheatstone bridge. Okay, it is used to find unknown resistances. Unknown resistances or resistance. It's a meter bridge because it uses a wire of 1 meter length. That's why it's called meter bridge. Okay. How it is? There used to be one wire. So wire like this. Okay. On this one, here one resistance is there, and here also one resistance is there. Out of that, one is unknown. Let's say this is unknown, and this is known. And here is galvanometer, and this is jockey, right? And then you have connected this with a battery. So current goes from the battery, current goes here, current goes here. This is also having resistance. This is 1 meter length. Okay, this is also having resistance. So when we are having moving the jockey in such a way so that resistance ratio comes out to be in the same way, so that here no current flows. That means potential here and potential here become same. Wheatstone bridge, same concept. Here also we get such a resistance so that this by this should be equal to this by this. So there is no current in that. Okay. So we will be getting this unknown resistance. How? Because we know this, and we know this. So 3 resistances we know. One we have to find. Okay. So suppose now this is X length. Then what is this? This is 100 minus X. And suppose per centimeter its resistance is lambda ohm per centimeter. So what he will write according to Wheatstone bridge? P by lambda X equal to, suppose this is Q. So Q by lambda into 100 minus X. Lambda gets cancelled. What we have to find? Q value. So Q value is what? P into 100 minus X by X. X we know because X is length. We can measure. 100 minus X is length. We can measure. So 100 minus X also you know, X also you know, P also you know. Q we got it. That's meter bridge. Let's see what questions are there. Balancing length for X resistance is 20 centimeter. What will be balancing length for 4X resistance? Nothing is given. Okay. So suppose one resistance is X and other resistance I am assuming is Y. And here is this wire. And then you have this galvanometer and there is a jockey here. So suppose this is given. What is the length? 20. So if this length is 20, then this length is what? 80 centimeter. We know that. What you'll write? X by 20 equal to Y by 80. Okay, so it says that Y is equal to 4X. Okay, fine. Now, what will be balancing length for 4X resistance? So in place of X, you want to have 4X. But other one is also 4X now. Y is also 4X. So what will happen? This is 4X, this is also 4X. Then galvanometer will be coming over here. What else? What you can do? Now, what do you say? This is L. Now, I know the answer. Why? Because both are same resistors, then they will equally divide the length. But okay, let's assume we don't know. So, what do you say? 4X by L equal to 4X by 100 minus L. This is getting cancelled. So, 100 minus L equal to L. So 100 equal to 2L. So L equal to 50. We found y is also 4x and you change x also into 4x. Okay. Right. See this one. 5-volt battery. This is x. This is 6 ohm. Balancing length is 40. So this is 60. What he says, lambda is 0.1 ohm per centimeter. Find x and I. So 0.1 ohm per centimeter. This is 40. So 0.1 into 40. That means this is 4 ohm. Then this obviously is 6 ohm. So what is the ratio? X by 4 equal to 6 by 6. X by 4 equal to 6 by 6. So that means x equal to 4 ohm. I am directly writing resistances. You can write that also, x by 40, 6 by 60. That way also fine. It will give you the same answer. Okay, so x equal to 4 ohm. Now what he wants? I value. Okay. So if x is 4, so this 4 and this 4 are parallel. Parallel, no? Because here and here potential is same, and here potential is same. So they are parallel. So this and this are parallel. So 4 ohm and 4 ohm are parallel. That means this is 2 ohm. And here 6 ohm and 6 ohm are parallel. That means this is 3 ohm. So total resistance 2 plus 3 is 5. 5 ohm. And here is 5 volt. The current will be what? 1 ampere. Okay. One more way is there. We can solve it with Wheatstone bridge. What we used to do? These two in series. So 4 plus 6, 10. 4 plus 6, 10. 10 and 10 parallel. That means 5 ohm. Okay. So that's all. This is what we have in current electricity. Ammeter, voltmeter. This we will study in magnetism. Okay, next chapter. So scan the code so that you can get the notes. Okay. So tomorrow morning will have class as usual. So here it is. Okay. Scan the code. Okay, students, then see you tomorrow. Bye bye.